Hello everyone and welcome once again to my channel. In today's interesting mathematics class, we shall talk primarily about properties of quadratic roots, and it is otherwise known as alpha and beta. I will show you how to evaluate these roots and to find their exact value. It looks quite complicated, but trust me, at the end of this lesson, you're going to be all smiles because I'm going to make it very simple and easier to understand. Without further ado, let's get down to business. Here we have a question before us that says the roots of the quadratic equation 3x squared plus 6x minus 15 equals 0 are alpha and beta. Find the value of the following we have right here. When you solve a quadratic equation, you're going to obtain two answers, which are otherwise known as roots. These roots we don't, let's assume we don't know what they are. Let's assume we don't know their exact value. It could be a 3, a 4, -1, -half, or whatever number. We don't know what it is that is for this very quadratic equation that we have here. Let's assume we don't know what their answers are. But we can call one of those roots, otherwise known as answers, alpha, while the other one will be called beta. Remember I said, when you solve a quadratic equation like this, you're going to obtain two solutions, okay? One of them, let's call it alpha, while the other one, we call it beta, okay? Now we're going to use alpha and beta to find the value of everything here. Let me show you what to do. For you to find the value of everything here, the first thing that you have to do is to find the sum of the roots of this equation and the product of the roots. And we have a formula for that. The formula is here. We have, I'm going to write my solution. The formula for finding the sum of roots for every quadratic equation is -b/a. This is a formula that's really very important, and you need to have that at the back of your mind. I'm going to say alpha plus beta. Remember, for the sum, which is the summation of the two solutions, okay, one of the roots is called alpha, while the other one is called beta. For this very equation, we've not solved this, so we don't know what the exact value of the answers are, but we can call one of them alpha or the other one beta. To find the value of alpha plus beta, which is the sum, we use this -b/a. This is the formula. With this, we can find our sum of roots. What is b and what is a? If you look at this quadratic equation here, there are numbers that we can find right here. The a is the coefficient of x squared. Okay, the a is the coefficient of x squared. Whenever you want to find your a, b, and c, the number in front of the x squared is your a. In this case, our a is equal to 3. Our b is the number in front of x. From x squared, we go to x. The number in front of x is our b. We say our b is equal to 6. And lastly, this is a constant term. A constant is just a number that does not have a variable attached to it. For example, if you have something like 15, 3, 6, they don't have any x or y attached to them. Therefore, they are called constants. In this case, our -15 is our c. Our c is now equal to -15. With this, right now, we can find the sum of our roots. This is -b/a, which is the formula. We say this is equal to, our b is a 6. We say minus 6 over, our a is a 3. I'm going to write a 3 here. This is equal to -6 divided by 3 is going to give you a -2. Hence, we have that our alpha plus beta is equal to -2. We're going to keep this aside and work with it afterwards. This is it. Our alpha plus beta is a -2. Let me clean this to avoid confusion. What about for the product we found for the sum? The formula for finding the product of roots is c/a. Here we have alpha times beta. Remember that the sum of the two roots is given by alpha plus beta, which is negative b over a, while the product, in this case, you're multiplying the two roots. It's giving us alpha times beta. This is equal to c over a. This is the formula. Okay, you have to have it at the back of your mind. This is equal to, what is our c in this case? You can see our c is negative 15. We have minus 15 over, what is our a? Our a is equal to 3. Write it here. This is equal to negative 15 divided by 3 will give us a negative 5. Therefore, our alpha times beta is equal to negative 5. With this right now, we can find the exact value of everything here. How do we do this? This is where it gets really interesting. It really gets interesting right here. And one thing you need to know is that in order to evaluate or to find the exact value of everything here, or these expressions right here, you need to manipulate them in a way that you will come up with your sum and your product. I say again, for example, you cannot just substitute a negative 2 for alpha plus beta here and a negative 5 for alpha times beta here. Why? Because you don't have them completely, like they are not actually isolated. They're not on their own yet. If you look at this here, do you have alpha plus beta here? No. Do you have alpha times beta here? No, you don't. Your task every single time you come across this kind of problem should be, or your question should be, how can I transform this function in a way that I'll have something like this and like this found inside all of this? I repeat, whenever you're given this kind of problem to solve, the first question you should ask yourself is, how can I transform these things into this and this? The two of them must appear in any of this before you can start solving. Otherwise, you're going to get stuck. There is no known way of doing it. You have to apply all the mathematical principles you know in order to get it right. Now, let me show you how to do it. Here we have the first one. I'm going to begin with my a. The a here is alpha squared beta plus alpha beta squared. If you look at this now, we don't have anything in the form of alpha plus beta or alpha times beta in here. How do we now solve it? Remember I said you must transform this thing into this and this before you can start solving. How do you do this? If you want to solve this one here, now we've seen that we have alpha beta plus alpha beta, which means that alpha beta is common between the two. In this case, we can factor out an alpha beta. Here we have two alpha. If you factor out one of the alpha, factor out one of the beta, you open your bracket, what will remain? Let's now try to divide. Alpha squared beta divided, we're trying to factor it so that whatever remains, we'll try to see if it's in the form of alpha plus beta or alpha times beta. So it's going to be quite easy for us to work with. Now you divide. Alpha squared beta divided by the one you factored. This is how to factor. Okay, once you pull out what is common between the two, okay, you now divide the original expression by what you pulled out. In this case, our original expression is alpha squared beta, while the one we pulled out is alpha beta. We now say alpha squared beta divided by alpha beta. This will give us an alpha because there are two of these here. Okay, we only removed one, we only have one, we now have one left. Okay, and that one that's left, we write it down here, plus the next one is alpha beta squared divided by alpha beta. It's going to give us just a beta because we have two of the beta, okay, and we have one here. So if you remove one from this, you only have one left. Now you've seen we now have something in the form of alpha times beta and alpha beta. And this is what we're looking for. Remember, we transformed this function. Like I said, find a way to transform this thing so that it will look like this and this before you start solving. We have now transformed alpha squared beta plus alpha beta squared into this. It's now very easy to plug in our values and solve. Let's now do that. What is our alpha times beta? We have it here as negative 5. This now becomes negative 5 multiplied by, what is our alpha plus beta? It's a negative 2. We say negative 2. Okay? Now let's multiply negative 5 times negative 2 will give us a plus 10. Therefore, the value of alpha squared beta plus alpha beta squared is equal to 10. This is our solution for the first one. We're now going to work on these ones here. I'm going to show you how to transform alpha squared beta, alpha squared plus beta squared into something that looks like this so that we can also solve the problem. Let me clean this part and continue with our solution. All right. I'm also going to clean everything here since we already have the values. Let's now work on alpha squared plus beta squared. Remember that I told you that you have to transform this because we only have alpha plus beta and alpha beta squared. Therefore, we have to transform this because we don't have anything that looks like this in here. How do you do for this one? Well, I know that if I do this alpha plus beta all squared, something like this, and expand it, if I expand the expression here, I am going to get this thing back. Okay? If I expand this, I'm going to get this. And if I get this, I'll make it the subject of the formula. Okay? And it's not going to be equal to something. This actually means I'm going to derive a formula for this. But I cannot just work with it as it is here. I have to expand this. Okay, so let's assume that you're giving alpha to the power of 3 plus beta to the power of 3. You're going to say alpha plus beta to the power of 3. Then you expand and look for something that looks like this in here. As you're simplifying, you make this one the subject of the formula. Let me show you what I mean here. Now, if you put the two of them in brackets, it means that they multiply themselves twice. Here you have alpha plus beta multiplied by alpha plus beta. Remember that we need this. Okay, we're going to make this the subject of the formula when we find it, and we now see how we can transform whatever is remaining into alpha plus beta and alpha times beta. Let's do that. We shall use everything on the left to multiply all we have on the right. Therefore, we say alpha plus beta all squared is equal to, let's multiply. We use the first term on the first bracket to multiply everything on the right. We have alpha multiplied by alpha plus beta, and the next one is plus beta multiplied by alpha plus beta. Let's now multiply them out. We have alpha plus beta all squared is equal to, alpha times alpha will give you an alpha squared. Alpha times beta will give you plus alpha beta, plus beta times alpha will give you alpha beta, plus beta times beta will give you beta squared. Let's continue. Remember, I want to transform this thing here, okay, into something like this. Now, you've seen that this one here that we had originally, which we expanded, we've seen it here. We've seen the alpha squared. We've also seen the beta squared. Therefore, we can combine them together, make them the subject, okay, and simplify whatever that is remaining into alpha plus beta and alpha times beta. Let me show you. Here we have alpha plus beta all squared is equal to, let me bring the alpha and the beta together. We have alpha squared plus beta squared plus alpha beta plus alpha beta. They are like terms, just like you have 2x plus 2x. These are like terms. When you have like terms in mathematics, what do? You add them together. Therefore, alpha beta plus alpha beta will give you 2 alpha beta. And this is it now. We've now seen that we have this one here, which we expanded originally. Remember, they said find the value of this. Now, what do we do with this, which we've gotten here? We can now make it a subject of the formula by moving everything that is with it across the equality sign, and whatever now remains is now equal to this. Okay, let me show you what I mean. We have alpha plus beta all squared is equal to, okay, I'm going to move this one here across. This is a plus 2 alpha beta. If I move it across this sign, it's not going to be minus 2 alpha beta. Remember, it's a plus here. It's a plus 2 alpha beta on the right. If I move it across the equality sign, which you've seen here, it's not going to be a negative value. This is now equal to, what is remaining here is alpha squared plus beta squared. You've seen, we found the value of this, okay, which is the formula. And now let's check if the formula has alpha plus beta and alpha times beta in totality. We've seen here we have alpha plus beta, it's on its own. We also have alpha times beta on its own. Therefore, it's complete. We have the sum and the product. The sum and the product, they're now complete. Therefore, we just plug in and solve. Okay, let's plug in and solve and see what we shall obtain. I'm going to clean this very part. On the left here, we have alpha plus beta. Whenever we see alpha plus beta, we put negative 2. This is now going to be, we open our bracket, negative 2. Remember, it is squared. We say negative 2 squared minus 2. What is our alpha times beta? Our alpha times beta is negative 5. As you've seen here, we say minus 5. The 2 multiplies the negative 5. This is equal to alpha squared plus beta squared. Okay, now let's simplify. Negative 2 squared will give you a positive 4. Okay, negative 2 times negative 5 will give you a positive 10. This is equal to alpha squared plus beta squared. Okay, now finally, 4 plus 10 will give you a 14. Therefore, alpha squared plus beta squared is equal to 14. This is the solution. This is not really difficult. All you have to do is to find a way to transform the function from the original expression into something like alpha plus beta and alpha times beta. Okay, you must have it whenever you simplify the expression before you can plug in and start solving. Now we found the value of alpha squared plus beta squared. Let's now go ahead and solve the third question here. This one actually looks complicated because it's in fraction form, but trust me, we can also simplify this to get what we want. Okay, remember, you cannot solve it like this because you don't have the product and the sum in totality. Therefore, you must work on it to get what you want. Let's do that right here. Here we have our C question, which is 1 over, here we have 2 alpha plus beta plus, the next one is 1 over alpha plus 2 beta, alpha plus 2 beta. How do we now combine this? This is a fraction, right? These are two fractions, two separate fractions. We cannot add them because their denominators are not the same. On the left, you have 2 alpha plus beta. On the right, you have alpha plus 2 beta. You can't add them together because they are not the same. Now, this fraction is in the form of, let's say, 1 over 3 plus 2, or let's say 1 over 4. Their denominators are not the same. You can't just add them together. You can only add them if you have a 4 on the left and a 4 on the right, or a 3 on the left and a 3 on the right. But as they are here with separate denominators, you cannot add them together. The question that you should ask yourself is, how can I get a common denominator for these two fractions so that I can add them up? How do you do that? Well, this is very, very simple. Simply multiply everything on the left by the denominator of the right, and everything on the right by the denominator of the left. Okay? You're going to multiply the 1 and the 2 alpha beta by the denominator of the right, and you're also going to multiply the 1 and the alpha plus 2 beta by the denominator of the left. This is what's going to help you to combine them into a single fraction. Let's do that, and I want you to follow me as we do this. Now let's multiply. Alpha plus 2 beta times 1 will also give you the same value. So this one here times 1 will give you the same value because any number multiplied by 1 is also the same number. Therefore, we shall now have alpha plus 2 beta over, let's now multiply again, alpha plus 2 beta multiplied by 2 alpha plus beta. We shall have 2 alpha plus beta in bracket multiplied by alpha plus 2 beta. Okay, now if you look at this right here, we've not multiplied them out yet. They're still in brackets, which indicates that I'm still going to multiply them again, okay, when it is time for me to simplify the fraction. I'm going to put my plus sign here. And what's the next thing to do? We have multiplied the denominator. We've multiplied the left part by the denominator of the right. I'm also going to multiply the right part by the denominator of the left. Therefore, we have 2 alpha plus beta times 1 will give you 2 alpha plus beta over 2 alpha times 2 alpha plus beta times alpha plus 2 beta will give you 2 alpha plus beta. Okay, then also multiplied by alpha plus 2 beta. Okay, we just multiplied the left by the denominator of the right and the right by the denominator of the left, which you've seen here. We now have a common denominator, right? You've seen the magic. We have the same denominator on the left as what we have on the right. Therefore, we can now pick one of the denominators and add them together. Let me show you what to do right here. If we pick one of the denominators here, what shall we have? We now have alpha plus 2 beta plus, here we have 2 alpha plus beta. We have 2 alpha plus beta over, what's next? We pick one of the denominators. Here we have 2 alpha plus beta multiplied by the next one here, which is alpha plus 2 beta. Okay, I just picked one of the two denominators because they are the same. Now let's add the numerators because we've seen some like terms. We have alpha, 2 alpha, beta, and 2 beta. Let's now add them together. Alpha plus 2 alpha, remember that they are the same. Alpha and 2 alpha are the same. They're like terms. So alpha and 2 alpha will give you 3 alpha plus, the next one here is 2 beta plus beta. They are also like terms, just like you have 2x plus x. Here we have 2 beta plus beta will give you 3 beta over, we can also multiply the denominator. Here we have 2 alpha times alpha will give you 2 alpha cubed, okay, 2 alpha squared rather, 2 alpha squared. 2 alpha times alpha will give you 2 alpha squared. 2 alpha times 2 beta will give you plus 4 alpha beta. Okay, remember how to multiply this. It's the first one against the first again against the second, and you're done. Now you go again, the second against the second against the second. Okay, let's do that very quickly. Since we are done with the 2 alpha, we've multiplied the 2 alpha by alpha, which we have here as 2 alpha squared. We've also multiplied the 2 alpha by 2 beta, which we have as 4 alpha beta. Let's now do the next one. Beta times alpha will give you alpha beta. Okay, it does not matter the order, whether it's a beta alpha or alpha beta, is still the same. But because we have alpha beta, this one has to be alpha beta so that we can easily add the two of them together. The next one is beta times 2 beta will give you plus 2 beta squared. Okay, we're not done yet because we don't have anything. Here you see we have 2 alpha squared. Here we have 2 beta squared. Therefore, they're not complete. We have our alpha beta, we have our alpha beta, we have our alpha plus beta, but we still have something left. Therefore, we have to keep on manipulating it until we have alpha plus beta and alpha times beta complete here. Let's continue. On the top, we have 3 alpha plus 3 beta over, let's now clean this one up. I'm going to bring the 2 alpha squared and the 2 beta squared together. We have 2 alpha squared plus 2 beta squared. I'm going to bring them together. Remember that addition is commutative. It does not matter the order. Okay, as long as they are adding up, it does not matter the order. This here and this, they're adding up. It doesn't matter whether I bring this one first or this one. It does not really matter. You'll still get the same answer. Therefore, based on this property, we can pick this and bring them together. And next up, we have 4 alpha beta plus alpha beta. They are also like terms, right? 4 alpha beta plus alpha beta will give you 5 alpha beta. Here we have 5 alpha beta. Next up, what do you do here? Well, you can just see if you can factor out the 3, because 3 is common on both sides. On top, 3 is found on the left, and 3 is also found on the right. Let's try to pull out the 3 to see what we shall have left. Remember, we still have alpha squared plus beta squared. Okay, therefore they're not yet complete. Let's see how we can transform this to get what we want. Let me factor out the 3 from the numerator. If you factor out the 3 from here, you have 3 multiplied by, okay, 3 alpha divided by 3 will give you an alpha, plus 3 beta divided by 3 will give you a beta. This is a transformation of the numerator over what's now left at the denominator. Here we have a 2 on both sides. Okay, we have a 2 on both sides. So what do we do right now? We can factor out a 2. Okay, because it's common on both sides. Let's factor out a 2. If you factor out the 2, what is remaining? 2 alpha squared divided by 2 will give you alpha squared, because the 2 and the 2, they cancel out. What is remaining? Alpha squared. Plus, on the other part, we have 2 beta squared divided by 2. The 2 here and the 2 here, they cancel out. What is left? Beta squared. We have beta squared plus 5 alpha beta. Now remember that this was the second problem we solved. Okay, this alpha squared plus beta squared, we got the formula, okay, and we solved it and we found that the answer was 14. Without me solving for it again, I'm just going to replace, because okay, I would say recall alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. Remember that alpha squared plus beta squared is equal to everything here. We did the derivation for the second problem where we got a 14, right? Now, what we're going to do here is that wherever we see alpha squared plus beta squared, we replace it with its value, and that value is everything here. Okay, since alpha squared plus beta squared is equal to this, wherever we see it, we replace it with this. That's what I'm going to do right here. So I'm going to substitute everything here for alpha squared plus beta squared, because that is what it is equal to. Remember, I said that these properties of quadratic roots, they don't have a specific way of solving them. It's up to you to keep on manipulating and manipulating until you get this one here, which is alpha plus beta, and alpha times beta in totality. It's up to you to decide how to work it out, and that's just how it is. So since I've found this now, remember we found the product, you've seen it here, we found the sum, it's also here, but this one is not complete yet. Therefore, we have to transform this into this one and this to make it complete. Let's now do it. Numerator, we have 3 alpha plus beta over, what do we have at the denominator? We have 2, okay, multiplied by what's inside the bracket. We have alpha plus beta all squared minus 2 alpha beta. Okay, remember that this 2 multiplies the value of alpha squared plus beta squared. And if alpha squared plus beta squared is equal to everything here, then this 2 also multiplies everything that is equal to alpha squared plus beta squared. What is now left is plus 5 alpha beta. All right. Now, this is what we're looking for. We've seen that the sum is now here. We have alpha plus beta, right? This is it here. We can now plug in our -2 right here. We also have it here again, alpha plus beta, it's right here. We also have our alpha times beta, as we have here. We just plug in a -5 here. And finally, we have alpha times beta here as well. Now, we have transformed everything here into this. This is more like the formula. Therefore, we can now plug in our values and solve for the exact value of this. Let's now do that. At the numerator, we have a 3 multiplied by alpha plus beta. What is our alpha plus beta? We have a -2 over what is at the denominator. Here we have a 2 multiplied by, we open our bracket, our alpha plus beta is -2. We raise it to the power of 2 minus, we have a 2 here multiplied by alpha times beta. And what is our alpha times beta? It is -5. You've seen it here. We have a -5 here. Okay. Then we also put this in bracket because the 2 multiplies everything. And we have lastly plus 5. This 5 multiplies the alpha times beta. And what is our alpha times beta? It's a -5. Therefore, we have a -5 here. Let's simplify. 3 times -2 will give us a -6 over. Now, let's simplify the bracket first before we multiply by what is outside. Here we have a 2 multiplied by -2 raised to the power 2 will give us a 4. Okay. Now, -2 times -5 will give us a +10. And what do we have left? We have outside 5 times -5 will give us a -25. Okay, let's continue with this. At the top still, we have -6 over, inside the bracket here, we have 4 plus 10 will give us a 14, okay, minus 25. Let's simplify further. At the top, we have a -6 over 2 times 14 give us a 28 minus 25. This is equal to -6 at the top. 28 minus 25 will give you a 3. And -6 divided by 3 will give you a -2. Therefore, the value of 1, I'm going to put it here, 1 over 2 alpha plus beta, 2 alpha plus beta plus 1 over alpha plus 2 beta is equal to -2. This is the solution to the third question we have right here. And this is how to do it. Okay, that was a very long one, and I believe you've understood how to do it. Let's now solve the last question we have here, which is alpha to the power of 3 plus beta to the power of 3. How do we do that? I'm going to clean up here and solve everything. Here we have the fourth question, which is our D, to be alpha to the power of 3 plus beta to the power of 3. We do not have anything, like I said always, I say always, you have to transform this into this and this. In this case, we do not have anything in this form, right? This and this cannot be found here as it is. We have to transform this to find everything here, okay? That means that I'm also going to say alpha plus beta to the power of 3. I'm going to expand this. If I expand this, I'm going to get this. Okay, just like we did for the alpha squared plus beta squared. I told you that if it's a power of 2, raise it to the power of 2 and expand. If it's to the power of 3, raise it to the power of 3 and expand. Even if it's a 4, 5, 6, or 7, you can also raise it to the power of, to its respective power and expand. Therefore, I'm going to raise this to the power of 3 and expand to see if I can get this. When I find this, I'll make it the subject of the formula and now simplify whatever is remaining to get the sum and the product. This is equal to, let's now expand. Remember that this multiplies itself 3 times. Okay, we have alpha plus beta multiplied by alpha plus beta multiply again by alpha plus beta. Okay, this is what we are looking for. Okay, we just make it the subject whenever we find it and simplify whatever is remaining. Right here we have alpha plus beta to the power of 3 is equal to, I'm going to take this 2 first. Alpha times alpha will give me alpha squared. Okay, or let me multiply it this very way. I don't know. Okay, this is just still okay. Alpha times alpha this way. Alpha times alpha will give you alpha squared. Alpha times beta, because it's this way. Okay, alpha times beta will give you plus alpha beta. Then next up, beta times alpha will give you plus alpha beta. Remember, our multiplication is commutative. Whether it's beta alpha or alpha beta, you still get the same value. But for simplicity's sake, here we have alpha beta and alpha beta. Let's also use alpha beta. And lastly, beta times beta will give you plus beta squared. And what do we have left? We also have the next one here left, which is alpha plus beta. Let's multiply again. Alpha plus beta to the power of 3 is equal to alpha squared times alpha will give you alpha to the power of 3. Next up, alpha squared times beta will give you plus alpha squared beta. We're done with this one here. Let's now do for this. Alpha beta times alpha will give you plus alpha squared beta. Next up, alpha beta times beta will give you plus alpha beta squared. Next up, we have alpha beta again times alpha. It will give you plus alpha squared beta. Okay. Lastly, alpha beta times beta will give you plus alpha beta squared. Now, what do we have here again? We have beta squared times alpha will give you plus alpha beta squared. Okay, alpha beta squared. Finally, beta squared times beta will give you plus beta to the power of 3. Now, let's try to clean this up by collecting like terms. Here we have alpha plus beta to the power of 3 is equal to, remember that we have now found what we're looking for. See it here, alpha to the power of 3, right? Plus beta to the power of 3. We can now combine them together as we have here, okay? Just like we did for the alpha squared plus beta squared. We put them together and made them the subject of the formula. Now let's bring them together. Here we have alpha to the power of 3 plus beta to the power of 3 plus beta to the power of 3. And what is now left? Let's collect like terms. We have alpha squared beta, and alpha squared beta. Okay, so we have alpha squared beta 1, alpha squared beta 2, and alpha squared beta 3. Do we have it here again? No. So let's just write it here. There are 3 of them. This is the first one, this is the second, and this is the third. Therefore, we write plus 3 alpha squared beta plus. Let's now check out for the next one. We've collected the alpha squared betas. Let's now check again. We have alpha beta squared. This is the first one. We have alpha beta squared. This is the second one. 2. We have alpha beta squared. This is the third one. Do you have another one? No. So we say plus 3 alpha beta squared, since there are the 3 of them, and we have collected all of them. We now have our alpha squared beta. We have it here. We also have our alpha beta squared. It's right here. There are 3 of them for both. Now, what do we do at this very point? Let's write this one again. Alpha plus beta to the power of 3 is equal to, okay, here we have our alpha to the power of 3 plus beta to the power of 3, okay, plus I have to now factorize. Okay, why do I have to factorize? I've seen that 3 is common on both sides. Okay, 3 is on the left, 3 is also on the right. Alpha beta is on the left, alpha beta is also on the right. Therefore, I can factor out 3 alpha beta to transform this equation. Remember that we are only looking for this and this. Once we're able to derive it from this expression, we can now plug in and solve. Until we have derived it, we cannot continue with the solution. We're going to find a way to solve or to derive it, otherwise we have to stop. Now, how do we do that? Since they're common on both sides, I'm going to factor out the 3. I'm also going to factor out an alpha beta. Since alpha beta is common on the left and on the right, I'm going to factor it out. Okay, whenever you have such an expression where they are common or they are common on both sides, you can factor them out and simplify. Once you factor it out, you just have to open your bracket, and now you now divide the original by what you pulled out. Okay, it's always the original by what you pulled out to check if you're correct. And when we do that, what do we have? 3 alpha squared beta divided by 3 alpha beta. Okay, we have 2 of this. We only have 1 here. So 3 alpha, or let's assume we want to do it this way. 3 cancel out with 3, that's gone. Beta cancels out with beta, that's gone. So alpha squared divided by alpha will give you an alpha. Okay, if you remove 1 from this 2 here, you're left with the 1 alpha. Okay, there are 2 alphas. If you remove 1 from it, okay, by dividing, you're going to be left with 1, which you have here. Next up, we have plus. Let's do again. 3 divided by 3, okay, it goes away. Alpha divided by alpha, it also goes away. Now, beta squared divided by beta, you'll be left with 1 beta, okay? We write it inside the bracket here. This is our beta, okay? Now, let's try to multiply it again to see if we'll get the original expression back. 3 alpha beta times alpha will give you 3 alpha squared beta, okay? 3 times alpha, okay? 3 alpha times alpha will give you 3 alpha squared, okay? Then you have, okay, let me do it this very way. 3 alpha beta times alpha will give you 3 alpha squared beta. And lastly, 3 alpha beta times beta will give you 3 alpha beta squared. So we are actually correct. Now we have this thing here, which is what we're looking for. You see it right here. We expanded this to get everything here. Now we shall now make it the subject of the formula by transferring everything here to the left. Okay, now it's not going to be equal to this. Let me show you how that is done. Let's do the transferring. Here we have alpha plus beta to the power of 3. Okay, so everything here, I'll move it across the equality sign. Remember, it's a positive. If I move it across, it now becomes a what? A negative. Here we have minus. We have 3 alpha beta. 3 alpha beta multiplied by alpha plus beta. Okay, the negative sign does not affect what's in the bracket, but it will affect it later. So when you transpose, it only affects whatever is outside, not what is inside, because what is outside will also affect what you have inside. This is equal to alpha to the power of 3 plus beta to the power of 3. Okay, now what next do we do at this very point? You see we've transposed everything here to the left. And what will remain is alpha to the power of 3 plus beta to the power of 3. Let's now plug in our values and solve. Why? Because we now have the sum. You see it here. We have alpha plus beta, it's complete. We have alpha beta, it's also complete. We also have alpha plus beta. Therefore, we can joyously now solve for the value of alpha to the power of 3 plus beta to the power of 3. Let's now do that by substituting. Alpha plus beta is equal to negative 2. We raise the power of 3 minus, we have a 3 here, multiplied by, what is the value of alpha times beta? It's a negative 5. We put a negative 5 for alpha times beta. This is multiplied by alpha plus beta. And what is alpha plus beta? Negative 2. We put a negative 2 here. Okay, this is equal to alpha to the power of 3 plus beta to the power of 3. Let's simplify. Negative 2 raised to the power of 3 will give you a negative 8. Okay? Now, negative 3 times negative 5 will give you a plus 15. So negative 3 times negative 5 is a plus 15. 15 times negative 2 will give you negative 30. This is equal to alpha cubed plus beta cubed. Let's now simplify. Negative 8, negative 30 will give you negative 38 is equal to alpha to the power of 3 plus beta to the power of 3. Therefore, we can now say that alpha to the power of 3 plus beta to the power of 3 is equal to negative 38. And here is our solution. And here we come to the end of today's interesting lesson, where we've talked about how to evaluate properties of quadratic roots, otherwise known as alpha and beta. In our next lesson, I'm going to show you more about this, and I hope to see you soon. Till then, bye.